Okay, so in this video, we want to review how to divide a fraction by another fraction. Let's start with a simpler version of this. So what if we wanted to perform 1 divided by, so 1 over, the fraction a over b? Well, there's two ways to think about this. If you take 1 over a fraction, what you're taking is the reciprocal of the fraction, its inverse, so it simply gets flipped. So you get b over a. You can also think of it this way. So 1 over a over b. So if you divide anything by a fraction, then you're performing the inverse, the reciprocal, which means that you are multiplying the top by the inverse fraction, the reciprocal of the original one, which is b over a. And of course, 1 times anything is that same thing, so b over a. So 1 over a fraction is taking the reciprocal, so you simply flip the numerator and denominator. Now what if you have a more general version of it, replacing 1 by another arbitrary fraction? So what if you start with a over b as the first fraction, divided by c over d? If we follow the same logic as in the special case, the numerator will stay intact, so a over b will stay a over b. And again, if you divide by a fraction, you're performing the reciprocal action, the inverse action, which means you are multiplying the numerator by the inverse fraction. So by now d over c. And now we know how to multiply fractions. This will be ad over bc. So this is how a division by a fraction works, but why does it work this way? Let's look now at a general argument in the general case why a over b over c over d is nothing but ad over bc. So multiplying the first fraction by the reciprocal of the fraction on the denominator of the larger fraction. And the argument is very simple. So let's start with this again. I'm saying the argument is simple because it is an argument that we have used before when talking about addition of fractions. So if you think about both fractions geometrically, right? The first fraction, again, thinking of starting with a circle, we are dividing up the circle now into b parts of equal size, and we are taking a of those parts. In this fraction, we are dividing up the same circle into now d parts of equal size and taking c of those parts. But if b and d are not the same, then we're taking ratios of pieces with different sizes, right? So if b is different than d, we have a pieces of a given size, and here we have c pieces of a different size. So the idea is, well, if we have a ratio of pieces, you need them to be of the same size. So you need both fractions to be under a common denominator. So the b is missing the d. So we multiply the first fraction by 1, choosing of course d over d. And the d now is missing the b. So we multiply the second fraction by 1, but of course 1 being, in this case, b over b. So now the fraction on top ends up being ad over bd. All over. And on the bottom we get cb, which I will write as bc, right? cb is the same as bc. Over, and same argument here, db is the same as bd. And now this is getting interesting, because you have a ratio of pieces of equal size. Right, in this case we're taking ad pieces after we divided up the circle into bd many pieces, and here we're taking bc pieces after dividing up the circle into, again, bd pieces. So the ad pieces we have here in the first case are of the exact same size as the bc pieces we have in the second fraction. So what we have ultimately are ad pieces out of BC pieces. And again, this can be done only because of the common denominator, which means that in each case, the pieces we have in the first fraction and in the second fraction all have equal sizes. So the ratio is simply AD pieces out of BC pieces, which is what we claimed to be the case. Let's look at one simple example of this special case to visualize why this should make perfect sense. But again, every time you perform a division of two fractions, don't think of it in the long way. Use the simpler rule, which is if you divide a fraction by another fraction, you simply multiply the top by the inverse, the reciprocal of the other fraction, and so you get AB over CD is AD over BC. Now let's visualize this argument, and again with a very simple example. What if we wanted to perform, say, 1 out of 3/4? Well, the rule would say simply, if you're dividing 1 by a given fraction, you get the reciprocal of the fraction, so you would expect 4/3. Let's see why this is the case. So again, we will visualize the fractions using a partition of a circle. So we have our circle as 1. So let's view now the original circle, which is 1, into 4 parts of equal size. Right, so the full circle, if we take all 4/4, gives us 1. So this circle equals 1. And now let's break it down into its 4 parts. And again, the key is that they are of equal size. So it's this part with this part. This part and the last part. So again, I want to emphasize that each part here is of the same size, an exact quarter of the full circle. So this is 1 now, our numerator, 1 viewed into 4 pieces of equal size. And you see what we're doing is what we did here. We're putting both the top and the bottom of the expression, so here 1 and 3/4, under a common denominator. If you think of 1 being 1 over 1, then what we should have here is 1 times 4, which is 4. So that's why we go here with 4 pieces. Let's now look at the 3/4, right? This is a numerator 1 into 4 pieces of equal size. Let's now look at 3/4. So we start once again with the full circle. We break it down into 4 parts of equal size. But we are not taking all 4 parts, we're only taking 3 of them. So this is 3/4. Now let me put the 3 pieces as I've done before. So we have 1 piece, the second piece, and the third piece. So now we have 1 broken up into 4 pieces of equal size and 3/4, 3 pieces of equal size. And each piece here is the same size as each piece here. Now think of what we're doing. We're doing the ratio of 1 of this over 3/4 of this. But this should be clear from the picture that the ratio is now 1, 2, 3, 4 pieces of equal size out of 1, 2, 3 pieces of equal size. And this is why 1 divided by 1 over 3/4 is simply 4 over 3, 4/3. So to conclude, And hopefully now this makes sense. Whenever you divide two fractions together, you keep the fraction on top as is, and you multiply it by the reciprocal, the inverse of the fraction on the denominator, and this is how you divide two fractions together, and hopefully this operation makes perfect sense. And that's it.